Video number 4, MATH996, fall 2014. Be real official here. Hey, when you log on, you probably noticed when you access this video that I uploaded a couple of links. We're going to start using Google Hangout probably next week, so that you need to be prepared next week, which will be, we're currently in week 3. So sometime in week 4, I'll schedule Google Hangout session with you. It looks like there's going to have to be two Hangouts. I've tried to come up with a time that we can all get together, but some of you gave me very, very limited time windows that you can meet. So I'm probably going to have to do 2, which is fine. So anyway, there's 2 video links that are up. One is kind of an introduction to Google Hangouts. And the second link is how to join a Google Hangout. So the first one's just an overview. The second link is probably the most important one because I'm going to be the one creating the Google Hangout. and your goal is just going to be to join the Google Hangout. So guys, let's get this going. As usual, these are short videos, and the importance of these things I guess are on the increase. Let's say that. Now, when I decide what to put up, what I'm ultimately getting at, there's a process here that I'm going to teach you and work through with you. But I think if you ask anyone, the most complicated and challenging part of doing your first, second, or even third research project is coming up with a topic. That I know when I did my dissertation for my doctorate, that was the toughest part. And when you talk to people, that seems to be a common theme. So anyway, what I try to do here is I'm trying not only to introduce you to the lingo of research. And today, as you can see here, we're going to look at the stages of research. I'm trying to give you examples of research that have been done in the education field. Now, some of these are mathematics related, and some intentionally aren't, because I want you kind of thinking more broadly and to see research that's gone on in other fields that you may use to apply for your master's thesis. So, guys, typical stages, there's 7. Select a problem. I'll just take you through a research that I did recently, and I wanted to look at the effectiveness of a particular placement tool. So, I noticed that our placement process at Shawnee State that we were currently using, I thought could be improved. So I wanted to come up with another placement tool. So that's when I selected my problem, just by kind of looking around me and thinking, there's something that could potentially be improved. The second thing I did is review the literature. I asked any researcher their least favorite part of research. Most people will say reviewing the literature. Reviewing the literature is important for reasons I'll point out here in just a second, because it gets you in tune, in touch with your topic. The third thing you do is you sit down and you design the research. This is a part that when I'm helping people or serving on doctoral dissertation committees, it seems like I'm usually left out of this stage, and that's a stage that's very important, because if your research isn't adequately and appropriately designed, you can get out to where, at the end, where you may not have collected the right kind of data to address the questions of your research project. So designing the research is extremely important. Collecting your data, that's pretty obvious. Number 5, analyze your data. The 6th thing, interpreting your results and stating your conclusions. And number 7, reporting the results. Typically, in the presentation of your results in writing, you have an introduction, which states the problem, officially states the research questions, and provides a motivation. Chapter 2 tends to be the literature review. Chapter 3 tends to be the research methodology, the design of your study. Chapter number 4 tends to be the data analysis. And chapter number 5 tends to be the summary. The two chapters that most people, I would say, least enjoy writing are the lit review and stating the conclusions. So it would be the final chapter. Guys, let's run through these. Selecting a problem. First of all, the problem should warrant investigation. It should be something that is important in your field. Now, it doesn't mean that you have to have unanimous support, that everybody you talk to is just sitting on the edge of their seat waiting on the results of your study. But it should, again, be important enough to justify your time and energies. Second thing, you don't want to repeat a study that's already been done. Actually, I know someone who did that. I don't know them personally. I ran into them in the hallway, but I knew of a person, probably more appropriately, who did some mathematics research, and they drug their feet a little bit and didn't get their research done as quickly as possible, or as quickly as they should have, I guess you would say. Well, in the meantime, halfway around the world, someone else is doing the same research, so they solved the problem before the person did at UK, and he ended up having to start over on his dissertation. Not cool. So guys, in selecting a problem, you typically begin with a question. Do children who are taught reading through the whole language approach score higher on reading achievement than children who are taught through reading through phonics? How do high school teachers deal with aggressive behavior? And what do high school math teachers know about graphing calculators? So those are three questions that, arguably may warrant investigation and could be selected as a problem. Number 2, review the literature. The main reason to review the literature is to get to get in touch with your problem, I think, so you gain more understanding about what you're going to study, and you want to determine what the research has already been done. I was told once by a prominent researcher at the University of Kentucky. In fact, his vita, his publications for example, my vita is about 15 pages long, and I didn't think I'd ever reach a stage to where my total vita was 15 pages. So I think that's kind of impressive until I compare it to the big boys and the big girls. One of the big researchers at the University of Kentucky was actually one of my co-advisors. His vita, I'm not sure how many pages his vita is, but just the part on his publications and his presentations is 92 pages long. And I take that back. It was 92 pages long in the early 2000s. And the guy is continuing to be a machine in research. So I don't know what it is today, but the second bullet there, or the large bullet, sometimes the beginning researcher will use the lit review to locate and formulate a researchable problem. Again, that's going to be one of the toughest things that we do here. Is we're going to sit down probably through Google Hangout, and we're just going to have some jam sessions. Tell me what's on your mind. And if you say, well, I can't think of anything, well, okay, let's end the Google Hangout session, and you need to go to work. Maybe you ask people. Maybe you read a couple of research proposals or research studies, and you're like, that'd be kind of interesting. So anyway, I didn't finish my story earlier. One of this prominent researcher once told me when I was kind of complaining that I couldn't come up with something for research. He said, Doug, look at what's currently been done. Put a spin on it that will cause controversy, that will get people's attention. So put kind of a unique spin on something that's already been done. And I actually kind of did that in one research. that I conducted just a few years ago. And the final bullet there, when it comes time to actually present your results in writing, you sit there with this blank slate. What format should you use? Well, I usually try to tap into previous literature or previous research and see how people have reported their results. And I do it according to the statistical technique that I used. So if I use a logistic regression model, then I look at research that's close to the area that I'm researching that has used logistic regression, and usually there's multiple examples out there. And I find one that I like the best and seems to suit my research, and I use it as a guide. The third thing, design the research. This is where you talk about the methods that are going to be used, any survey instruments, the data to be collected, and of course the statistical technique that you're going to use to analyze your data. The where, how, and who of designing the research, extremely important. Where will your research be conducted? Is it at a local high school? Is it a school district? Is it in southeastern Ohio? How are you going to conduct your study? What's the research design? And of course, who are the participants? Guys collecting the data, lots of different things can happen here. If you get into a control experimental design, you typically randomly assign your subjects into one of the two groups, and then you do something to the experimental group, and then you end up taking some measurement in the end to compare the results. That could be part of a test. Questionnaires, ratings, attitude scales, those are all fair game when collecting data. And I don't want you to get the cart in front of the horse and say, well, I know I want to use a test. Well, you don't know that. Let's develop the or for example, I really thought this repeated measure stuff was really cool. So let's do something like that. That's not what you do. You set up your design. You decide on what you want to study. You come and talk to me about that, and we come up with a couple of questions. And then we think what execution of your research plan would be most appropriate, and then we come up with the statistical technique based on what we've created. Number 5, analyze the data. Man, this is the cool part, except for the first part. First thing you have to do is cleanse your data. I usually do this in Excel, and you have to decide how you're going to handle your missing data. You end up choosing an appropriate statistical technique. And you got to remember, once you get to this point where you're analyzing your data, you're months into the process. And it's amazing how you can run the statistical technique in 30 seconds, and all of a sudden all that work you've been done, wham bam, thank you ma'am, it's over. You see your p-value, you see what's actually happening. So that's an exciting time when you start analyzing the data. Unfortunately, analyzing your data is followed by one of the most tedious things, and that's the interpretation and the conclusion, which typically goes in your chapter number 5. What you want to do here is very thoroughly report your results. Use p-values to test your hypothesis and make conclusions in the context of your study. And always consider potential biases and threats to your study. I served on a doctoral dissertation committee last spring, I guess it was last April, because they flew me down to Fort Lauderdale because the student was doing an online PhD program at Southeast Nova University. So she was defending her dissertation down there, so they flew me down for the defense, and I did a good job. There were some issues with some things, but I asked her, give me one threat to your study. And what do you mean by that? Well, tell me something that someone could look at, could read your study, and could come away thinking, I don't know about this. So she struggled with that, and then afterwards we all went out for a drink and dinner, and we talked about it a little bit more. All right, number 7, report the results. Guys, it needs to be clear and concise, sufficient detail, and again, talk about potential biases. And most importantly, again, this will be chapter 5, discuss potential future research. Typically, that's what happens in chapter 5, so you might put that on your radar when you go out here and you're trying to come up with a research idea. Look at some things that have been done, go to that final chapter, and look at suggestions from the researcher that they have for ideas for future research. Okay, questions asked by educational researchers. First thing, we get into what are called theoretical questions. These are like, what is it? How does it occur? Why does it occur? What is intelligence? What is creativity? How do people learn? Why are some children more motivated than others? What happens here is the researcher goes out and conducts a study that is geared toward developing a theory. More on theoretical questions. Again, it's typically focused on developing new theories. And this is where you can get rich and famous if you can do that. In fact, I know a guy who took mastery learning, which was developed by Ben Bloom, and put his spin on it. His name was Tom Guskey, and became very, very famous in the field. Then second bullet there may focus on testing existing theories, and the beginning researcher often investigates hypotheses deduced from theories of learning, personality, motivation, and so on for ideas for their research. Other questions that we run into, aside from theoretical questions, are practical questions. Practical questions are, wow, imagine that, direct and practical. I can't believe I wrote that. Well, that's a bonehead statement, but so let's just say practical questions are direct. They're usually aimed at solving specific problems, and for the kind of in the context of where you're expected to go with your master's thesis. We hope that your research will lead to an improvement in teaching and learning, or in programs. So Slavin, a guy that I've studied quite a bit, he's pretty fancy schmancy in the program evaluation community. Made a statement there that I shared with you. So hopefully that'll drive you to become this incredible researcher. Examples of practical questions that we may run into. How effective is peer tutoring in Algebra 1? How do non-English speaking parents feel toward their children's high school as compared to English speaking parents? What are the most effective means of providing remediation to high school math students who are falling behind? How effective is a newer method for teaching fractions? Now I'm kind of jumping all over the place here intentionally, because I want you to see just how broad the community of education research is, even how broad education research in mathematics could be. For example, the second bullet there, you could just put a little spin on that and focus on how they feel about their children's high school math experience, for example. So always think about something that I give you that you can put just a little spin on it to create your direction. Basic and applied research. Basic research is aimed at obtaining empirical data used to formulate and expand theory. It's not oriented in design and doesn't have the purpose of solving practical problems. It's just geared at either creating theory or expanding on theory. Applied research aims to solve immediate and practical problems. These things are often teaching and learning. So you guys are probably, considering the time constraints that you're under, you're probably going to do some applied research. But if you guys are game and your group wants to get into a theory and do some stuff, well, I'm on board with you. Trends that are currently going on. Basic research has tended to move more toward classroom studies, and applied research may help basic researchers complete theoretical formulations. Researchers developing general learning theories may go into classrooms and try to find out how children learn. Now, a couple of examples here. Mastery learning is something developed by Ben Bloom, and what he wanted to know is he had a very simple question: why do some students learn and other students don't? So he just decided, he wanted to learn this, and he ultimately ended up creating a theory. So what he did, he just went in a couple of grade school classrooms and just sat in the back of the class and just watched. And what he found out with mastery learning is a couple of things. He developed a theory that says, all students can learn, but sometimes it takes, oftentimes students need longer to learn something than other students, and that the whole testing process is geared toward rewarding the students who learn the fastest. But it doesn't say that the students who don't learn as fast aren't capable of learning. So I don't know if you know much about mastery learning, but mastery learning is a process by which you teach a concept, teach a unit, and you give an examination, and any students that have 80% or higher on the exam go on to a more advanced part of the unit. Students who have 79% or below are given another opportunity to learn the material, and then they're tested a couple of days later. Mastery learning, you continue in the same unit until you master that particular you continue learning that unit until you master the material in the unit. Supplemental instruction, something that was developed at the University of Kansas City, Missouri, actually in a medical school. And the administrators for the medical school noticed that there was one class, oddly a statistics class, that gave medical students a lot of problems. In fact, a lot of very capable medical students dropped out of med school because of this one class. So they found, instead of coming in with all these prerequisite classes that they need, that if students are given more opportunity to be on task, then oftentimes they don't necessarily need the prerequisite material. I see that a lot in my Math 1500 classes. We've got places where we need to solve radical equations. Like if we're solving for a sample size to create a particular margin of error for a confidence interval that deals with the proportion. But you got to ask yourself, does that student need an entire 5-hour class in developmental math for that one concept? Well, the supplemental instruction idea says, well, we can add this extra instruction every week that's appropriate to what's currently being expected to learn in the class, and we can add maybe 20 minutes of instruction on how to do radical equations, which makes them more effective in statistics. So that was developed actually in a medical school at University of Kansas City, Missouri. And we actually have a supplemental instruction program at Shawnee State, which has shown to be extremely effective. Well, guys, that's it, as you can tell. And you know what? Have a good one.